Hey everyone, this is Daniel from Hawkridge Systems.
Hey, Daniel.
Hey.
So I wanted to go over a few things with everybody today. We're like, put this out as expand your manufacturing capabilities, using your existing SolidWorks tool. So a lot of what we're going to cover early on is actually what's already inside of SolidWorks, which would be like the CamWorks solids, and things like that. So as we get going through here, Daniel and I get going. So Daniel and I like to do a couple things. I usually play the manufacturing guy and he plays the engineering guy. So we want to figure out how to communicate between what's happening in the office and what's happening on the shop floor. So that's a lot about what we're going to cover today and see if we can't bridge that gap that everybody seems to be fighting in the world as we get going here. So I guess that's all I have to get started with. Daniel?
A few of the products that we're going to be addressing today, obviously Hawkridge Systems covers a lot of different products that you can see on the screen there. But some of the products that we're going to be discussing are SolidWorks, obviously for the CAD side of it. We're going to be looking at inspection, NBD for model-based definition and how those tools can annotate your models. We're going to look at SolidWorks Chem, like Tim mentioned. SolidWorks Chem Professional as well, the extended capabilities that you get from bumping up to the Chem Professional package. Look at machine simulation, either CamWorks Virtual Machine or Eureka, and then also Predator, and everything being encapsulated by SolidWorks PDM. So with that, let's get started. So I've got some files right here. We've got these foot pegs that we can we're going to use throughout the presentation here. So we drew these in SolidWorks. We've got all these drawn as a multi-body part. We've got a drawing already made for those as well right here. So talking about inspection processes. Now, I don't know about you guys, but my boss used to come to me and always ask me to basically sit there filling out an Excel spreadsheet and going through each dimension in this drawing and basically annotating them. And it used to drive me nuts until we got SolidWorks Inspection. So in SolidWorks Inspection, essentially what you're doing is you're creating your first article inspection reports and automatically ballooning all the dimensions on the drawing, creating that first article inspection report in Excel or a PDF so that you can actually give it to your QA guys, your quality assurance guys, and basically have them fill out all the information when they're doing their checks and check to see if everything's in spec or not. So SolidWorks Inspection is an add-in. You can get a standalone version as well for it. So you just go turn on your inspection add-in, comes in right into the drawing interface. You start off by creating a new inspection project. We'll just restart one here, starting from scratch. So we've got our template. This is where we pull in things like our part information. So things like our custom properties that are in the SolidWorks file, you can see it pulls in things like, hey, my description's right there, my part number is right here. What revision is it that I'm doing? I'm on revision, say, A of my part file. And you can also put in different document numbers, vendors, and things like that too. Now, if you've been outsourcing stuff, we, in this case, are going to use some of the internal stuff, but you can customize all these lists up at the top up here and go through and edit those lists and dial it into exactly how you guys produce your components. Obviously, you go through your process, you tell it what you want it to actually register and pick up on, so you can filter out certain dimensions. That's what I'm going to do in here. We're just going to let it go and hit everything. And we can tell it the precision range that we're working with. So angular precisions, things like that. And it goes through and we'll go and balloon our drawing automatically. Now, I would waste hours just sitting there doing this day in, day out, just going through, annotating my drawing. And then ultimately, I see one error that I've made. No one ever makes mistakes, right, Tim? So
No, not you, especially.
especially me, I always make mistakes. So in here, I've noticed that there's a dimension missing, right? So we've got all of our balloons on our drawing already, but I noticed that I missed off the center line distance between these two holes. Maybe that's some critical dimension that we need to go in and put in here. It would help me if I actually grab my dimension tool. But we go through here, we go and place our dimension. Maybe we go and position that dimension as we see fit. But just like SolidWorks keeps things parametric, Inspection's trying to do the same thing. So if I go and hit Update Inspection Project, it's going to go and look and see if there's any dimensions being missed or added, and you'll see right here it flags up that 2.5 inch dimension. And I can just quickly go and say, yep, I want to add this to the drawing, and it adds it to the inspection sheet. Now, one of the big things I like about this is we've got this critical tolerance on our bore through this bushing right here. We've got a bushing that's sliding in here and it needs a press fit. So what we're going to do is we've got a tolerance on here, but we need to specify how we actually inspect that tolerance. So we go and find our 0.472, which is our dimension 27 right here. And we can go and tell it exactly what method that we want to use to inspect it. Now, Tim, we're using bore gauges for this?
Yes, I will on this one.
Okay. So maybe we'll go through and set our that up as a dowel bore gauge. Maybe we'll go through here to our 0.25 dimension. So the nice thing is I can either click on the dimension or I can click in the tree over here and basically it will give me the information that I need. So maybe we'll just mic this with a caliper or something like that. So we go through, we build our information, but this is the bit that really used to take its time. Everyone loves Excel as a really powerful tool. It's available all over the place. But the problem is that manually creating all that data entry is time consuming. I have other things to be doing. I got other drawings to make. So I can actually just take this entire project in inspection and export it to Excel. I can create a separate standalone project. So if I've got QA guys that are not in SolidWorks, they just want to basically look at the inspection data outside of SolidWorks, they can use the standalone version, or we can even export it to PDF if we really want to just create that kind of snapshot in time. I like Excel, so we just choose our templates right here. It's going to go and create that document for us. So we go and choose exactly where we want to save it, create our inspection sheet, and this is going to write all of our data to that. Now it could be depends on your inspection processes and things like that. You might be doing a sampling ratio, and you can kind of go in and input that sort of information. In this case, we're going to just have part by part inspection. So these templates can be customized to exactly as you see fit, and we've got one just using the standard template that's included right here that I really like. So it goes in and creates our inspection report. You can see the method that it's going to go through and test it. So we're going to use digital calipers on there. We've got our upper and lower limits. So the great thing, Tim, that I think that's going to save you a lot of time if you're checking to make sure when you're at the machine, hey, is this part inspect? Do I need to adjust some tool or some offset or something like that? You can probe the part, go in and say, okay, well, is it inspect? Well, if I type in and I measure it to 0.5, I've done a pretty bad job, right? And it's obviously way out of spec, not recoverable for this hole. But if I go and say, actually, hey, in this case, it's not 0.47, it's not out of spec, we're using, say, 0.472, you'll see it automatically color codes in it so that we know exactly what's going on out on the shop floor. So super useful. Create the inspection reports. It also creates a bunch of extra data as well over here for all of your sampling information and things like that. Gives you your part information. But I really like that. Keeps it nice in check.
It makes it easier for me too. At least I know what to look for that way.
Exactly. Yeah. So speaking of what to look for, now I spoke to the engineering manager, and they don't want to go towards the full model-based definition right now. They're maybe looking at it in the future for a later date. But right in here, we can still run model-based definition. Now, Tim, do you know what I'm talking about? MBD?
No, not really.
Okay. So you know when I hand you a paper drawing, right, and you look at it and you read off all your dimensions and you sat there looking at this kind of snapshot in time and it doesn't ever match the model?
Yes.
Or there's some sort of disconnect, like, hey, did you mistype something in here or whatever? Or did you click on the wrong spot? Well, rather than creating a separate 2D drawing, we can actually put all of our machining information in the 3D file. So let's take a look at this, say, adjustable arm, for example. Now, I mentioned that there was a couple of different flavors of MBD. You can get the full MBD package where you can create 3D PDFs of your drawings and have everything in 3D. We're not at that stage right now. You can create step 242 with all the product manufacturing information in it. I'm just going to do something simple for you, Tim. I'm going to help you out and put the tolerances in the model, just so you know exactly which ones are the critical tolerances. So I'm going to go in MBD, put in a size dimension right here, and put my tolerances in here, because I think you guys said that you can run these tolerances in SolidWorks, Cam. Is that right?
I can, but so what you're telling me is the parts actually can match the blueprints now?
It should do. All being well, unless you screw up.
Nice.
So in here, we can go and look at the properties of that particular hole. We can go and specify our tolerances. So in this case, we're going to do a bilateral tolerance of plus 5 thou minus 0. So it's got to be a little bit bigger. And obviously, we want to increase our dimensions over. So we're just putting in our dimensions in our 3D file, essentially. In this case, we're creating a 2D drawing just for the shop floor. We're not fully set up with MBD yet. But we're trying to keep the data as much as possible in the 3D file. And I'm sure that's going to help you out. If I just go through here and flag up all the critical dimensions, right, at least you'll be able to see them in the model. So I'm going to go and work on that tombstone I think you were asking me about earlier.
Okay.
Do you want to show these guys some SolidWorks Cam?
Yeah, I'll jump right on that. Let me share my screen here. So here's the model that Daniel just designed and everything, and you can see the actual MBD down inside here, right? So the great thing about this is now my parts are going to match what's on the blueprints, which has always been tough for us between the shop floor and the office. Sometimes, don't take it wrong, Daniel, but sometimes you'll just throw random numbers at it, and then the blueprints don't match the model. So I'm glad to see this is different now.
That's a different Daniel.
That's the other guy. So inside here, this part is actually all designed and ready to go inside SolidWorks Cam. So what I'm going to show right now is exactly what's already in SolidWorks. It's already good to go. So first thing I want to do is there's a couple tabs inside here. I want to double click on the machine, and then that'll tell me which machine I actually want to run inside the part. So I can choose from a mill or a lathe. So I'm going to pick on the mill. I'm going to hit select on that. My tool crib. What machines do I like to run inside, or the tools I like to run based on different parts and models. So I can tie it to a tool crib and say, hey, this is my tool crib, this is the priority, use this first. But then I can lock it down and say, don't use anything that's outside my tool crib, or I can leave it open and say, hey, anything that's outside my tool crib that I might need, like a drill or a tap or a reamer, it'll go ahead and add that in there for me and flag it so I actually know to add it. Post processors, I can go inside here. I can just go up here. I picked this one off the website. I can hit select, and this is just off the website at Hawkridge, so it gives me the information inside there. And then any different setup information, posting setups, things like that. But I'm just going to hit OK right here. And from this point, I can choose my stock. I'm going to double click on that. And there's a lot of different stock options inside here. So I'm just going to leave it kind of generic. I know people want to put 20 thou on top and a 1/4 inch on the bottom and all this other stuff. But I'm just going to put 0.1 all the way around for now. That way we can just go ahead and just machine the whole part complete. So get that going inside there. I hit OK. And now at this point, I'm just going to extract machinable features. So what it's going to do is it's going to start analyzing the model, figure out all the 2D pockets, holes, bosses, things like that, and then start getting the model all configured to what needs to be machined. So you can see inside here, I have a setup. Right, kind of goes through, roughing, finishing, things like that are all dialed in here. But I don't want to do a rough and a finish, right? And what's happened, these are strategy names. So I've gone through the company and I've dialed these in, right? And I said, okay, when we do it this way, this is how we like to do it. And you'll see a little bit of that further on down inside here. So if I right click, I can go to parameters and I can actually change it and say rough and finish. Or as a whole, I can go into the strategies and I can set some defaults, and you can see here it's found 4 of these, or 3 of these and 3 of these, right? So if I pick on this, I can choose rough and finish. I can pick on this, pick rough and finish, and I just hit apply, and it changes my tree according to that. One thing inside here, Daniel wanted this hole actually reamed. So if I go to the TBM, which is tolerance-based machining, this is going to read the MDB information. So I'm going to pick on this, make sure your checkbox is on, and then what happens, it finds the range, right? It says, hey, based off this hole is drilled, you have 1 of 1. So what it's doing is going through now, and it's figuring out based off this tolerance that he put in there, what I actually need to do with that. And it's saying, okay, based off this, based off what you told me in the database, I'm going to have to ream this. So I can pick on that. I pick on the paintbrush, it analyzes my information, and it changes this hole now to a reamed hole, which is huge, right? So I don't have to think about or go back to the blueprint that may or may not be right. It's actually reading the data exactly off the model and giving me the information. And then I can just hit OK.
That's nice. I like
it has
that.
multiple. You like that? See, now we're starting to tie together, right? What you guys are doing, I'm getting the information, not having to guess.
Yeah, I'll be putting that on the drawings from now on. I'll give you the files with all that information.
Awesome. It makes my life so much easier and quicker to be able to do that and understand what's going on. Instead of trying to go back to the tree, go to the blueprint, come back out, walk into your office, right? And then come back out. So
yep.
Much better. So you can see I do have different setups inside here. It shows all the different stuff, everything's inside there. One thing to remember in SolidWorks CAM, it does not do indexing. You just have to post each setup out. And this is the standard version. We'll get to the other later. So I did leave everything on. So, and the reason I did that is because it'll just program the whole part. So meaning there's a part perimeter feature, right? And then down here on this side, there's another part perimeter feature and another part perimeter feature. And the reason I did that is because I want to show that you can delete those. I can go into the part perimeter feature, I can hold my control key down, and I can pick on those, and I can just hit the delete key, and it goes away. It doesn't matter if it's in there or not. You have full control of the software. I can even minimize it. The next step, generate an operation plan. Go through there, and it starts generating the information that we actually need now. So, you know, the facing, the tools, and stuff like that. So if I want to sort all this, I can just sort it from the top. Let's say I just want to pick on this one right here and sort, right? I can sort operations because what's happening is it's doing a rough and a finish, a rough and a finish, a rough and a finish. And it's because over here it says rough and finish the feature. So I don't want a bunch of tool changes. I don't want the machine wearing out. I just want to put the one tool in and do everything I can before I change tools. So I'm going to highlight this, sort the operations. And then what do I want to sort by? I want to do maybe all the face first, and then I want to do the rough mill and drag those, and then do the contour mill and pull those, and I hit apply, and then it changes everything within that setup. It doesn't mean that I don't have full control still. If I want to do this roughing first, I can still take that up and do that first. So that's not a problem. And then when I generate toolpath, I now have the toolpath to go through and run all that information. And then there's my toolpath to do that. What is that? Daniel?
What?
What is up with you and fillet? I mean, you think every tool in the world fits everywhere. What is this?
Me. That was the other Daniel again.
All right. Yeah, point 08. You know, I'm going to send this back into engineering. And can you make this bigger? Because I at least need a 1/4 inch tool or 3/8 tool. Otherwise, this is going to take forever to machine.
Oh, no, you should be able to change that. That's why we got PDM. So you guys are all in the vault. You should be able to change that. Just make sure when you check it in to put a note in there that you said you changed it to suit manufacturing processes.
Yeah, but last time I changed it, they got mad at me.
No, that was back when we were using all your when you're using all your desktop folders and everything else, saving everything in all sorts of different directories. That's when they got mad.
Got it. So I'm going to double click on this fillet right here. I'm going to go through and make that change. Oh, sorry, I'm going to right click and edit the fillet and make that design change. So I'm going to go bump this up if you don't mind, Daniel, so I can get a bigger tool in there. I'm really just going to go to 125 so I can use a 1/4 inch tool, or a little bit bigger. I'll make it force through there.
Perfect.
So I hit OK on that, and I'll check that in there. So now you said I got to check it back in so you're aware of it?
Yeah. Just go over to your PDM tab on the right there.
Okay.
Yeah, just right click at the top there. and then just go check in. And then when you hit check in, then you can put a comment right down at the bottom, and you'll be good to go.
Perfect. That'll work. And the other bonus here is when I'm doing all this, it's updating the cam at the same time. So if I hit OK, it is now modeling all that, and it's actually adjusting my tools to fit inside there properly. So huge benefit to being inside SolidWorks and doing all your machining inside SolidWorks. So now I'm updated, I got the right information in there, and then I can make a comment, you know, made 0.125 on fillet.
Made correct.
Perfect. And then I could make, sorry. There you go.
See, everyone does typos.
Yeah, you can't shoot the machinist, right? I'm not the engineer here. I'm going to check that in, and then now that's all checked into PDM, and we're good to go at this point. So now you're aware of that. We're communicating back and forth.
Perfect.
And then over here, you can see that my tool path is now updated, and I have the right tools that are now set up in there with my 1/4 inch tools. Okay?
Perfect.
I'm going to get this posted out. Let me simulate this really quick. If I simulate tool path, you can just see it run. So let me speed this up. So there's all my tool path now to make the part. I can do that. And then I'll get that out to the shop floor, and I'll get that running. Okay, awesome. So the prototype is done, shop floor. Okay, Daniel. Now what have you been working on?
I got that tombstone ready for you. I checked it into the vault, and you should have it. I went through and just made sure you could get access to it a little bit earlier. So you should have it in your window already.
Up inside here?
Yeah.
Here we go. Perfect. So what's happening here is it's asking me to rebuild this because the corners changed, right? So now I'm transitioning from SolidWorks Cam Standard to SolidWorks Cam Professional and getting this all going here. So now it's going to show me what's changed, what's happened, and then it's all communicating back and forth while I'm running here. So one of the big things about this, I just want, you know, this is SolidWorks Cam Professional now. So as I go through this, Daniel asked, you know, there's a couple critical tolerances on here, right? Daniel, why is there tool path already on this?
Oh, I took your file and imported into it. I don't want to waste time, waste your time having to reprogram it all at this level. I just took your prototype part and imported it and put it in there for you.
Okay. Awesome. Saved me a couple hours of work there. I appreciate that. So that works. I didn't have to reprogram anything. So, okay, but a couple of things I need to add here. You've done that inspection report, and you're telling me that there's a critical tolerance in here. So I do want to change a couple things. Now that we're actually inside SolidWorks Cam Professional, I could probably speed up the tool path here. So if I double click on this, instead of using just standard tool path, I can go inside the rougher, and now volume mill is an option, right? So I can do the high-speed machining inside of this thing. So if I look at the operation, it's about a minute, you know, based on however the feed rates, things like that are going inside there. So now if I take it, I can go to volume mill, and then it's going to ask me, hey, the pattern has changed, right? And it has this expert, right, that actually goes through and tells me what the feeds and speeds should be. So now instead of trying to guess it, I just hit yes on the OK here, and it opens up the information. Now it knows that I'm going to run aluminum because it was based off the drawing in SolidWorks as aluminum. Or I can go into here, put alloy, whatever I want to do. I can modify it if I need to. I can set different things up inside here. The coating, what's the coating on the actual material, or the tool, sorry. How am I holding it? Is it poor? Well, you know, it might be, or it could be good or better or best, right? So I'm going to go with better. And then what size taper I want to use. So it kind of knows by default what to set up inside here. And then you can see the different things that are set up here as well for the feed rates. And I can adjust those, right? I can be conservative to start with, maybe get the part running, feel a little safe, and then we can start dragging it up and then go from there. So it just depends how I want to do that. I'm going to hit OK. That's going to take that tool path. I hit preview, and it's going to go through and rework that tool to go down inside and actually cut all that out. So you can see it gets off the top a little bit. So inside here, Daniel, a lot of people, when you start programming, they might miss this. There's 3 dots right here. And inside those dots, it gives you more control, right? You want to spiral, plunge, ramp in, whatever you want to do, right? And you could see the toolpath didn't go all the way up in there when I was on it, right? There's an adjustment here. I could say, hey, make this, I don't know, we'll make it 15 or whatever, right? And that allows the tool to start squeezing down tighter into those tight spots, right? And now the tool is really working where it needs to up inside that radius that we changed earlier. So a great way to go through and fit all that stuff inside there. So now I'm going to hit OK. And now I have that information done as well. So the other thing I want to do is I want to do in-process inspection. So I'm going to take that information right here. I'm going to go down to my ream tool, right? So I have my reamer, right? And right inside here, I'm going to right click and I'm going to insert a probing operation. So I have that. I'm going to take my tool, hit the checkbox. And now here's a bunch of things inside probe, right? So I can go through. So the great thing I like about probing is it's all individual. So in SolidWorks CAM, when you program this feature, it runs this feature as well because it's a parent-child relationship, which we like. But when it comes to probing, I don't need to probe both parts, right? I can probe every other part per se, and no different than pulling a part off the machine and putting calipers on it and going from there. So if I take this, I can just now go through, turn this a little bit. I can pick on here. It automatically sets it up as a bore. And then there's my probe now set up to do that information. And then I can hit OK. And now I have my probing. So at this point, if I look at this and I go through this whole part, I'm pretty comfortable with this. I'm not too sure about the way Daniel put this part in being held, but he convinced me that it'll work. So I had to put it sideways myself, but you know, all of us machinists were all different.
For sure. For sure.
So at this point, Daniel, I'm done. I need to check a few things. Can you run this through our simulator?
Sure can. Do you want to jump on that turning part that I just sent over to you real quick? And we'll take a look.
I can do that. Since I'm already in SolidWorks CAM Professional, I might as well run that part as well. So if I go to Windows, and then the shifter peg, right? So I have this as well set up inside here.
Yep. So
the biggest thing is you just got to change it to a turn part now, right? So when I was in there earlier, you saw where I went through and I set it as the mill part. Now I'm going to set it as the turn part. Just going to hit OK right there, and I have that information set up. So it's the same concept. I'm just going to extract machinable features, right? It's going to analyze the model, pull the different features. It found a face feature, an OD feature. So if I pick on that, you notice it didn't dip into the part. It said, here's a groove, here's another groove, and I can reorder these however I want, right? And then I'm going to part it off. So based on the features that you drew, Daniel, you're getting much better at this. I have to say, it's starting to find stuff better. You don't fill it everything anymore like you used to. I can now generate an...
Sorry, learning to be a machinist, Tim.
No worries. It's all good. Our parts are definitely getting better with all the technology we're starting to use back and forth. It opened up the communication a lot. Then I'm going to generate toolpath. And now there's my toolpath to run that actual part. So if I was to simulate this, I could go in and turn this down a little bit, and then there's my tool actually running the simulated part now to go in and machine it.
Nice. You make it look so easy that I might be able to try and do some of the stuff, take some workload off of you.
Right? Well, just so you know, I'm not going to start doing drawings because I'm not very good at SolidWorks.
Oh, no.
So you can just double your workload.
Yeah. Well, I'll have more time now that we got inspection taking care of things. Let me bring up that machine simulation real quick, and let's take a look at it together. So I got the code on the left here. We just got our tombstone right here. We exported it straight out of CamWorks from machine simulation. So this is coming from CamWorks specifically, straight into Eureka. And we've got all of our fixtures. You'll see we've got our vise hanging off the side of our table right here, just to kind of maximize the production. I think there's 12 parts in this entire thing. So I see lots of times when we're just kind of sticking one part in there at once and calling it quits. But we've got our G code coming up. We've got all of our work offsets passed over to our machine simulator right here. and we can just play through this and see what it looks like. So we're going to backplot this, and maybe I can use this to try and learn some stuff about the code as well if I'm getting started with it, just to test things out digitally rather than actually. So
Well, the good thing too, Daniel, I mean, that's an expensive machine, right? So even for me, I've been doing this for years. I mean, look how close your head is to that vise, right? I could bump into that, and then all of a sudden I have a crash on the floor instead of right here.
Yeah, exactly. So particularly when this thing's spinning around, it looks like it's getting pretty close to things, and it is using collision detection right here as well. So it's gonna tell us if there are any collisions, if I'm doing anything stupid. Let's see if it finds anything here. Oh, yep, it stopped right here, and it warned me that the tool's hitting the fixture right here. So if we go in, it looks like it's kissing it. We maybe make some tweaks to it, but
Daniel, it's aluminum jaw, right? So
yeah.
I'll just slow it down on the first pass through. I can either cut a notch in there and get that out of there, or I can just slow it down, let the face tool take the first pass off, and then from there I can speed the program back up. I just have to pay attention to that now you pointed it out.
Yeah, it looks like we're pretty good on the actual height over here. We're getting up there into the machine limits, but we're pretty close. I think we should be good accessing all that sort of stuff too. So I think we should be good.
So,
yeah, go ahead.
I do have to say, I'd have never thought to put that vise on there, but now that you and I communicate a lot and you put the vise on the side, I actually like the idea.
Yeah, well, there's a mounting holes for it on the side of the actual table, so why not stick it in there and start using it, right? Try and get some productivity out of this thing.
Yeah, I guess I was always scared, right, a bump in the head, but now that we have the simulator, I can see it beforehand.
Yep. Yeah, we can certainly jog things around too. So if you wanted to ever move things around and check anything out, this is how I was checking out the limits on that UNC 500 just to make sure everything was going to be clear, and it wasn't in that case. We didn't have enough Z travel in here, so we switched it over to the UMC. So the 750, sorry. I'll drop that code into PDM, right, and we'll get it sent over to the machine. If you want to head out there.
Yeah, I do have a question really quick, Daniel.
Sure.
Samuel was asking me, is there a way to set up a pattern? So every time I right click and I say sort tools and I have to drag and drop, can I make a scheme in there beforehand?
Yes. Yeah, I answered that question already. So you can actually set the schemes in the database, and they'll come into that lower right-hand side window when you're in the saw operations dialog. There's a little drop-down where you can select multiple different schemes.
Perfect.
So yeah, basically we've got our code put into our PDM vault. So we're using SolidWorks PDM to manage all of our programs as well. So we've got things like our inspection reports in here. So things like if you wanted to take that inspection report that's in Excel and tie it to the SolidWorks drawing, I can actually right-click in here, copy, and paste it as a reference. And what that's going to do is create a relationship between these two that will say anytime this changes, this also needs to be updated as well. So obviously those two go together the same way we're going to deal with our code as well, Tim. If we want if our part changes and we need a second rev for the actual code, like rev A, rev B, we can do all that with our code too and put all that into here. But so we've got all our code as well.
Yep. I mean, what about all my USB keys that I carry around on the floor? I mean, what's up with that?
Just give them to your kids. Give them to your kids. We don't need that anymore. We got it all set up in here to communicate direct from PDM to the actual CNC. So right in here, I've got Predator all set up, communicating to my UMC 750 right here, and it's waiting for information. So it's waiting for the actual program. So right inside of PDM, right over here, we can actually just right click, send to CNC, and this can all be customized. We can send it direct to the CNC. It fires it off, and you can see actually sending it out to PDM. So, out to the actual CNC. So the code will be ready for you at the machine when you get out there, Tim. Uh,
So
I meant to ask.
what you're telling me is this is inside SolidWorks PDM, and
Yep,
you're sending it all the data that I've produced for G code to the floor through our PDM of SolidWorks.
exactly. Yep. So we're managing all the files. If
Wow.
customer X comes back in 6 months and goes, "Hey, this part broke, and it was Rev A, but we're on Rev D," we can always go back to Program A, load it into the machine, send it to the CNC, and we've got basically all of our history of our programs all managed through SolidWorks PDM. So super nice. Now, did you get that email from manufacturing and sorry, the engineering managers about that lean manufacturing stuff?
I did, but my head is still swimming from doing all the PDM stuff. You guys took all my folders off my desktop, right? And now you want to add something else inside here. I guess, can you explain to me what that is? I didn't really dig into it, man. I'm trying to keep the shop running out here.
Well, hopefully by being more efficient with all of the machine tools and being able to analyze all the information, we want to streamline the entire manufacturing process, and PDM and inspection and everything else is part of that. But also we need to make sure that the machines themselves are running efficiently. Are we seeing any downtime, things like that? Is a machine always breaking down? Is it always requiring a lot of setup for some reason? Maybe the operator isn't as experienced setting up that machine and he can run this other machine super quick. So they want to be seeing how effective we are at an all platform level. And I was doing some research on the web, and I saw on the Predator website there's a machine data collection right here. So this is, I've just got
Okay.
it bookmarked right here. So it's right on the website, and I can actually look at my efficiency of my machines and see, okay, what is my overall efficiency? Well, 63%, but I can also dig down into each of these machines right here. This looks like it might be a good fit. It tells us when a machine's idle, how long is it cycling for. So I can look at machine downtime as well and see any information about, oh, is it on feed hold, or is it active, or hey, why is the robo drill basically is never down, or is it not running, or is it not communicating to this? Maybe we have a communication problem to it. So we can also get them reports. So I think this might be good for management just to push forward and say, well, why don't we just take the information direct off of the existing Predator setup and use that information to say, okay, when are we cycling? When are we running that information? And we can see, okay, which machines are cycling, what job they're running, when it started cycling, and who's running it, and things like that. So, what do you think?
This will work really good because I actually thought that we were going to be done with the UMC 500 yesterday. And then, when you did the design work, you figured out that it wouldn't fit anyways, but I was going to try to put this job on there, and you said we had to run the 750 because you caught that collision in the simulator because of the height of the head. And this will actually help me better with planning to make sure we have the right machines running and have the work going through in and out.
Yep, for sure, for sure. So we'll
You
put
know
that
what
up
though?
to management.
I was just thinking the other thing too is we can check against is the estimates, right? I mean, I'm on the shop floor and they're telling me I got to cut these parts in 5 or 6 minutes or 10 minutes or an hour or whatever, and I'm having a hard time wrapping my head around how they're figuring that out. And you know what?
Yep,
I bet this will help bridge that gap because they'll actually see, hey, you know what? It took, whatever, an hour and a half, and this is why, right? This operation was this feed rate's that. It pulls
yep,
all that information inside there.
yep, exactly. And they can all see this as well from a management perspective. They can see this on a live feed right to their tablet or wherever they're at. They can always get access to this information. So if they're out at some board meeting or out at lunch getting some nice expensive lunch, then wherever they're at, they can see all of this information and monitor it. So, and we have better data as well if we're running into issues as well on the shop floor, or if we're not pumping up enough drawings through to them. Then basically they'll tell us all that stuff, and we can get all that ironed out. Or maybe we need to expand and add more equipment and things like that. So
Okay. No, I like it.
okay,
We'll have to see if we can get that in here and get it going.
perfect. Guess we'll get talking to some rep at Hawkridge.
That works.
So
Those guys are really good guys. I like those guys.
Yeah, they helped us out with the implementation and everything else. So in terms of PDM and things like that, making sure that all our workflows are all dialed in on point with their support. So guys, today we were looking at obviously a few different packages. We talked about obviously some SolidWorks, some inspection, some MBD in terms of the CAD side of things. Tim showed you some of the SolidWorks CAM capabilities, the standard version on that individual part file that we looked at. Then we looked at the professional features, things like indexing, the ability to use an assembly. So rather than just an individual part, being able to take that tombstone, stick a bunch of parts on it, stick a bunch of vices in there. That assembly is in there as part of SolidWorks CAM Professional. He also showed you the volume mill side of things for high feed milling, tricordial milling, dynamic milling, chip thinning, all that sort of stuff. Showed you the turning side of it, the probing side of it as well. All those tools are all in SolidWorks CAM Professional. Then we took that assembly, put it over into CamWorks, used CamWorks and the ability to export to machine simulation from CamWorks and simulated that either in Eureka or virtual machine, same software essentially. And we put that code into the PDM vault, the SolidWorks PDM vault, and sent that directly to the CNC from Predator, through Predator from the PDM vault. You can see the different packaging layouts that we were kind of talking about right here. So all the ones in green there, the tolerance-based machining, the parts machining, the feature recognition, the knowledge base, the post generator, that's something that Tim didn't mention, but the CamWorks post generator is available for you if you want to create your own posts, or you can download those ones off our website or contact us if it's something specific. And also the CamNC editor to be able to backplot the code and see what the code is doing itself. All the ones in light blue there are the ones that Tim mentioned in that session. So, and finally on the Predator side of things, communicating to the CNC, there is a CNC editor as well from Predator themselves, but the machine data collection was that tool that we kind of displayed right at the end there that was discussing all of the machine information, calculating the overall equipment effectiveness and part of that lean manufacturing push. And with that, well, take care, guys. Enjoy the rest of your day, and we'll speak to you all sometime soon.
Thank you. Appreciate your time.